Hey guys, this is for those of you who were confused on some of the Bellwork questions. I'm just going to go over them one at a time, kind of like we do in class. Column 1, we are simplifying the square root of 384. Okay, so we know our perfect squares, at least 1 through 12, but it ends in a 4, right? So it should be divisible by 4 or 16 or maybe even 64. Okay, so those are my perfect squares off the top of my head. I'm going to get out my calculator and just try things. Okay, so I'm going to do 384 divided by, well, let's just see for fun. 64 is 6. Okay, so I do know that I can break down 384 into the square root of 64 times 6, right? And I do have this 4 out front that's being multiplied by the square root of 384. Okay, and the square root of 64 is 8. So the 8 comes out. All right, and I'm left with 4 times 8, and the square root of 6 is left over. So this is 32 square root of 6. Okay, and you might have got it another way, but as long as it is simplified as much as possible, then that's fine. Okay, column 2 says, using properties of special right triangles, find each missing side in radical form. Okay, so I see a 30, 60, 90 is what we're going to start with. So here's my 30, 60, 90 right triangle. And I have sides x, x root 3, and 2x. This one looks like it's going to be easy. So I have 6 root 3 equals x root 3. I set x root 3 equal to 6 root 3. And I'm solving for x, right? That's this x right here. Okay, so I divide both sides by the square root of 3. And I get x equals 6 root 3 divided by root 3. Okay, and anything divided by itself is 1, so I have x equals 6. Right, so x is 6. And this is going to work out really nicely. 2 times x is 2 times 6, which is 12, right? And that's not something that I need for, well, it's something that I need to use to solve for y and z, right? Because in my 45, 45, 90 triangle, I have two side lengths that are the same, right? I have x, x, and x root 2. So if x is 12, right, for my 45, 45, 90, then y is 12. Okay, and I'll just plug it in for z. If I have x and y are both 12, okay, then this is going to be 12 root 2 for z. I just substituted 12 for x. Okay, and then number 3, or sorry, I guess this is number 5. We are completing the square. I know this is your favorite one, so here we go. The first step is to bring c over to the right, which it already is. All right, then the next step is to divide all the numbers by a to eliminate my a term. Okay, so I have 1x squared plus 2x equals 90 divided by 8, which I'm just going to simplify to 45 over 4 because I'm just dividing both sides by 2 because usually if it's able to be reduced, we want to, right? And then we take half of b. So this is my b term. We take half of 2, square it, and add it to both sides. Okay, so 2 divided by 2 is 1. 1 squared is 1. We're adding 1 to both sides, but on my right side, I'm going to add it as 4 over 4 so that I'm able to add my like denominators. Okay, x squared plus 2x plus 1 is a perfect square trinomial. So I have x, and the square root of 1 is 1. Okay, this is my sign in the middle. It's x plus 1 squared equals 49 over 4. Okay, and so at this point we take the square root of both sides to solve for x. I now have x plus 1 equals square root of 49 is 7, and the square root of 4 is 2. So I write this as x plus 1 equals plus or minus, right? X plus 1 equals 7 halves, and x plus 1 equals negative 7 halves. And we subtract 1 from both sides, so I'm going to subtract, oh, I didn't mean to do that. I subtract 1 here in the form of 2 over 2. And here in the form of 2 over 2. Okay, and that brings me to 7 halves minus 2 halves is 5 halves. Negative 7 halves minus 2 halves is negative 9 halves. Okay, so that's my solution set. I have x equals negative 9 halves. I should make it smaller. Negative 9 halves and 5 halves. Okay, almost done. So if we're converting to degrees, we multiply by 180 over pi. Okay, the pi's cancel. And 180 divided by 6 is 30. I should have known that. 180 divided by 6 is 30. So I have negative 7 times 30 is negative 210 degrees. Okay. If we're converting to radians, I multiply by pi over 180. All right, so, oops. I'm just reducing. I'm just going to divide by 5 because I think that might make it easier. So 180 divided by 5 is 36. And 75 divided by 5 is 15. Okay? And then I can see that both of these are divisible by 3. So I'll reduce again. Dividing by 3, that's 5 and 12, right? So that's 5 pi over 12. All right, so that's my answer, 5 pi over 12. Okay, hope that helped. And tomorrow's your Bellwork quiz, so you should be getting used to it by now. If you need to go back and watch this video or watch some algebra nation to help you to get tomorrow's Bellwork quiz right, then I recommend doing so. All right, bye.